Hi guys, I wanted to take a few minutes to go over some plate tectonics basics with you. And that's something that we have covered in class as well, but I figured by recording a video I can allow you to rewatch it if need to be. So first what we're going to do is we are going to start with some internal structure of the Earth. And if you recall, at the very center of the Earth we have our core. Okay, and the core is where we find a lot of radioactive material. Okay, so it's important that you remember that a lot of radioactivity takes place within the core itself. Beyond the core, we have the mantle. Okay, and this is obviously not to scale. Okay, we have mantle beyond the core or above the core. And then above the mantle, what we have is our crust. Okay, that's where our crust is. Now you should remember that we have two types of crust. Okay, we have a continental type, and we also have the oceanic crust. Okay, the thing about continental crust is that it is less dense. Okay, and by default that makes it, the oceanic crust, more dense. Okay, and within the oceanic crust, what we have is a break within that crust itself. Okay, so I'm just going to try to make it look like this. So then what we have, let me see if I can, I erase that. So anyways, there's a break in here which will allow for some material to come up from the mantle and show up at the surface. Okay, what we have in here is one of the mid-ocean ridges. Okay, that's where the two oceanic plates are coming apart. Okay, so this would be your oceanic plate, and then in here you would also have an oceanic plate. Okay, now as this new material is coming up, what happens is that those two oceanic plates spread apart. Okay, they move away from each other in this direction. Okay, what that allows the magma to do coming up from the mantle is to continue to do so. So as these two plates are moving apart, as they're spreading apart, they're creating new space for that new material from the mantle to come up. Okay, so we are constantly adding new rocks as that magma coming up. That lava is actually solidifying, creating new rocks. So as you move away from the mid-ocean ridge, from this portion right here, the age of the rocks is going to change. Okay, here are your brand new rocks, okay, that are just forming right now, and as you move away from the mid-ocean ridge, your rocks are going to get older. Okay, so you're going to have old rock formations in there. Now you may ask, okay, if the oceanic plate keeps going and keeps creating new plate, right, or new rock formations, where do they go? Because they can't just pile up on the other side, on the opposite side of the planet. And they don't. What happens is actually they will eventually reach a continental plate. Okay, so we're going to I'm going to draw this thing as a continental plate. Okay, I'm going to label it so you know. So this is your continental plate. And now, knowing that the oceanic plate is more dense than the continental plate, once that oceanic plate reaches the continental plate, what it's going to do is actually going to submerge underneath the continental plate, okay? So it is going to be submerged underneath the continental plate and eventually return to the mantle, okay? And the same thing happens on the other side, right? You're gonna have your oceanic plate submerge underneath your continental plate in here. Okay, it's going to be your continental plate again. Now, you may ask, okay, what happens because of that? Well, if you think about two enormous rock structures coming together and rubbing against each other, they create a lot of friction. And with a lot of friction, you create a lot of heat. So there's a tremendous amount of heat at this boundary here at that subduction zone. And hot material will rise because it becomes less dense, so it will actually burn through that continental plate and eventually reach the surface, creating a volcano. Okay, that's where all that material is going to be surfacing at, is at a nearby volcano or a volcano nearby the boundary here. And the same thing might happen on the other side, where we have that friction taking place in here between the two plates rubbing together, right? And that hot material is going to rise because it's less dense, and it will create a volcano, which will allow that hot material to surface and harden as volcanic rocks on the surface of the Earth. So knowing all this, we can look at a couple of other features within our planet. So within this area here, where we have two plates coming together, right? So if you could imagine a continental plate, okay, with, so I'm going to label it continental plate, with an oceanic plate coming in and submerging underneath. Right, this plate is coming in this direction. This is your oceanic plate. And like I said, there's a lot of friction going on in here, right? And if you think about friction, think about heat, right? You have a lot of heat being produced when you have two surfaces rubbing against each other. Think about your winter time when your hands are really cold, you rub them together to warm them up. Same thing happens between those two plates. There's friction, that material is molten and eventually rising to the surface and erupting as a volcano, okay? And we see that in the United States at the Pacific Northwest region, where we have a lot of volcanic activity. In addition, what happens, because of this friction between those two plates, there's a lot of energy that's being built up between those two plates. And eventually that energy is going to be released, right? So, and what you're going to create is earthquakes, okay? Earthquakes happen because of friction between those two plates. So eventually there's enough energy being built up between those two plates that the plates will actually snap back into place because the oceanic plate drags that part of that continental plate along with it as it submerges deeper into the mantle. And eventually that's too much stress for the continental plate, so it will snap back into its preferred location, creating an earthquake, okay? This plays in in the area, we refer to it as a trench. Okay, trenches are the deepest part of the ocean, and it happens because of this area being dragged by the oceanic plate as it submerges. Okay, we call this process, this entire area, a subduction zone. Okay, because plates, in particular oceanic plate, is being subducted underneath the continental plate. Now, you can have a couple of different types of plate boundaries, okay? And we have three main types, the first one being convergent. Okay. Convergent type of plate boundary happens when two plates are coming together. Okay. They're coming towards each other. Okay. Again, there's a lot of friction. Okay. And with a lot of friction, we will have volcanoes and earthquakes. Okay. Now you can have different varieties of convergent plate boundary, okay? Because you may have two oceanic plates coming together. Okay. For example, Japan is a good example of that. You can have a oceanic and continental plates coming together, and you can look at it in the Pacific Northwest in the United States. And then you can also have two continental plates coming together. And those would be your Himalayan region, where you have two continents smashing into each other. Now, with two continental plates, because we have two plates that are coming together and neither one of them is going to submerge underneath the other, you are going to have huge mountains building, because that crust has nowhere else to go but up. Okay. The next type of boundary that you can have is a divergent boundary. Okay. That's when you have two plates coming apart. Okay. They are moving away from each other. What do we create? We create the mid-ocean ridge. Okay. And we see that in Mid-Atlantic ridge that we generally use as an example for divergent plate boundary. Our last type of boundary would be our transform. Okay, and within the transform plate boundary, the plates are moving past each other. They are sliding past each other. Neither one of them is being submerged underneath the other. So in terms of diagrams, we can have a convergent plate boundary. We have one plate coming or being available here, and then another plate that's approaching it this way. Okay, so they are coming towards each other. A divergent plate boundary is where we have two plates that are moving away from each other. Okay, and then transform, we have two plates that are sliding past each other. Okay, so neither one of them is being submerged underneath the other. There is an area within the transform plate boundary right here, and that is referred to as a fault line, okay? And that's the, fault. That's the area in which the two plates meet with each other and they slide past each other. And a good example in the United States is the San Andreas fault line. Okay. I hope this video helped you understand and review the basic plate tectonics features, and I will see you in class.